Hi, hello, namaste. This is Reddy. So, today we are going to see how to learn classical mechanics. The main motive of our series is to provide the way to learn physics in a simple and easy way. Let's start. We will see the one by one. Welcome to today's session, which we will focus on classical mechanics. It's a first part. We will see the following sessions as well. Right here, myself, Dr. Reddy Emani. I'm a teacher and a physicist. Completed a doctorate from University of Hyderabad. So I am here to share my knowledge with you, and I'm very excited to start this session. Here we will see why the classical mechanics is important for us. For your kind information, even though we have so many other mechanics and areas developed, especially quantum mechanics and advanced modern physics, but still classical mechanics is important in order to understand any subject. Not only that, it is required for us to understand day-to-day life activities in a simple manner. Those things whatever we are doing daily, like walking, running, bus, vehicles, their motions, force, everything we can do in quantum mechanics. But the problem is it's a very complicated mathematics where it leads to like more confusion rather than the clarity. So to develop modern physics, the foundation is from classical mechanics only. Say for example, the development of the Hamiltonian. So basically Hamiltonian we will use in order to derive the equation of motion. In mechanics, the main purpose is to derive the equations of motion, whether it's a classical mechanics or quantum or statistical, where along with the equations of motions we will study about the how the energy is changing or how the energy is getting interacting with different systems. Shows that even though present day technology is more advanced, still we cannot discard this classical mechanics for our studies. It's important. Now we will see what is classical mechanics, how we before 20th century up to there whatever may be developed, that will be treated as right classical theory. In that classical theory, classical mechanics is a branch where the main areas is like Newtonian mechanics, Lagrangian and Hamiltonian mechanics. So the main purpose of all these mechanics is simply to understand the motion and extract the relevant parameters such as force, energy, momentum, how they are getting interacted with one another. And whereas the key areas, especially in case of classical mechanics, will be Newton laws and its applications, Lagrangian and its applications, Hamiltonian and its applications, Hamiltonian equations and Poisson brackets. Not only these, we have some more other areas where this classical mechanics deals, such as central forces. Planetary motion is the main part where we will discuss. Then it's a small oscillations, rigid body dynamics. Now we will here see the summary of the classical mechanics, what it is exactly is. So here what we are doing is we have the classical mechanics, basically physical space, phase space, configuration space. So based on the space we will use separately different types of mechanics. When come to physical space, we will use the Newtonian mechanics. In that, Newton's second law is the basic requirement which shows the equations of motion. It's defined as F is equal to dp by dt, where rate of change of momentum is equal to the net force acting on the system. When come to Lagrangian, the problems whatever we are arising in Newtonian mechanics is reduced in Lagrangian and Hamiltonian mechanics with the help of, instead of dealing with the forces, here we will deal with the energies. There is the transformations we use once we want to transform from Lagrangian to Hamiltonian, Hamiltonian to Lagrangian. So those are called Legendre transformations. So all these, whether it's a Newtonian mechanics, Hamiltonian mechanics, or Lagrangian mechanics, all will provide the equations of motions only. So whenever we are dealing with the formalism of the mechanics, we require a basic mathematics. As we know, mathematics is a language of physics. Whatever we want to represent in physics, that we will use a mathematic for simplicity. So in this, we required more rigorous mathematics, especially coordinate systems and its relations. Whenever we are describing the motion, we require different types of coordinate system. For example, Cartesian coordinate system, where we use x, y, z, especially in 3 dimensions, and polar coordinate system, position and angle r theta, or spherical polar coordinate system, or cylindrical coordinate system. These type of coordinate systems we required based on the, so there we required these different types of the coordinate systems, and the transformation from one coordinate system to another coordinate system is also required. And whatever may be the system we use, that will provide the same information only. Next one is basic trigonometry and vectors. So to represent the vectors like velocity, force, accelerations, and if we want to do the arithmetic in the vectors, vector algebra is the basic one. Not only vector algebra, vector calculus is also required, where whenever we are dealing with a gradient, and differentiation, integrations are inseparable part of the physics. Once we want to be in physics, we have to be familiar with differentiation and integrations, not only basic ones, but advanced level also you require to understand, especially when we use the study of the equation of motions, or when we are writing the waveforms. There we will use sine, cos, and all those transformations we will use. Apart from this, we require a matrices and series. These are very useful for calculating the eigenvalues and eigenfunctions, whichever may be related to energy spectra. Apart from this, the representation of the graphs play the key role in physics, especially. A picture is equal to 1,000 words. So to understand the concepts, whether it's a directly proportional or inversely proportional, how the object is moving, always we will use graphical representations. Apart from this, we required special functions, numerical calculus, and numerical analysis. And nowadays, computer programming also we are using C, C++, Python, Mathematica. Not only that, some softwares are required additionally in order to show in 3D diagrams and all other. So those things we can see especially in coming series. Now we will see what are some of the learning resources, especially for the people who are in studying classical mechanics and want to study classical mechanics further. So when come to the resources, there is a good number of the books. The list will be maybe unlimited, but for the simplicity, I kept 3 books here. Mostly we read at M.Sc level and for B.sc level as well for competitive exams. One is J.C. Upadhyaya by Indian author. Another one is a Goldstein. It's a famous, and you can learn more theory. But for my sincere advice is, if you are starting to learn classical mechanics, don't directly go to the Goldstein. You will be lost in it after reading 2-3 pages. So once you get the familiarity with the classical mechanics, then you can enjoy this Goldstein book. And another good book is Rana and Joe. So this is a nice book. You can find good number of things and related information which can be very helpful for you. Next one is especially online lectures in online we can find a great number of people and lectures starting from MIT, Open Courseware to NPTEL. So here I am representing just two eminent personalities. One is Professor V. Balakrishnan, Classical Mechanics. This link you can find in NPTEL HRD, and another our well-known our Professor H.C. Verma. He is also dealing with the classical mechanics. You can find in YouTube channel GDS KS. If you want to read classical mechanics or just to try to understand simply, here are some books which are not what we can say is not the textbooks. They are like a supplementary books. And if you are a common person to look into what this classical mechanics and how to study, these books will be good for you. First one is Jacob No Nonsense Classical Mechanics, a student friendly introduction. Another one is a Patrick Hamill, a student's guide to Lagrangian and Hamiltonian, and John L. Bone, the student guide to analytical mechanics. So the last two guides is from I think Cambridge Shocks Press. You can find online all these books, whatever the resources I am referring. Uh, this part 1 on classical mechanics. In the future, we will move further in detail about this Hamiltonian, Lagrangian, Newtonian mechanics. Not only that, we will focus on other areas also, and we will continue in the next session, this part 1, where we will see separately in depth of Newtonian mechanics, Hamiltonian and Lagrangian, how to deal with and what are the resources and how to understand them in a simpler manner. So for up to that, signing off, your Shivnag Reddy Emani. Thank you.